Yo. Yo, SKF. Oh, I see. Is it live or? All right, let's continue here with. I have a couple. I don't have as much time today, so I have like maybe, let's see. Well, I guess 4 hours. So let's get moving here. Okay, so I see. Okay, so let's see where. Okay, yeah. So last time we did a bunch of LSP stuff, type checker stuff. Yeah, we got the lookups thing working for the outermost scope. Really cool. And of course, if you try to look up something, I wonder if we send like an empty string, if it would show anything, or maybe we should, well, like if we get null, we just don't show anything, I guess is better, probably. Something going wrong? Okay, there we go. No information available, it says done. Okay, cool. Yeah, that's way better. And then it's like over here, it's like, no, there's nothing there. Okay, cool. Oops. Awesome. So, yeah, what I want to fix now is being able to also inspect inner scopes and also fix this bug here. This bug is probably pretty easy to fix, so let's start with that. Actually, let's do that first, just to get warm in the clothes a little bit, as we say. So this would be the type checker, and we have like run binding. Actually, it would be more run assignment. So apparently, yeah. So how the assignment works is basically the type checker runs across an assignment expression, and first we validate the expression of the assignment, and we also check the identifier if the identifier is correct. If it's not found, we just bail out from this thing, and if it's not found, it's also reported here, so we don't need to do anything here. We just need to know that it's not found and return. But if everything looks good, we get down here and we can now materialize the binding type, which basically means that you provide an identifier and you provide a type, and the idea is that this identifier would now try to be assigned to this. And the why I call it like materialize is basically because of maybe this identifier doesn't have a type yet. It might turn out that we can always get the type, but right now it's unknown, or it might be unknown. Sorry. So and then the thing we send in also might not be known. So if it's not known, the thing we send in, then we don't do anything basically. If it's known though, and we get then we can look up the binding ref of the name. Now this should happen, or this should always be the case. Otherwise we actually get an actual compiler error at this point, because we shouldn't call this function if we don't have the name. That should be checked before. Maybe I should add that in kind of like a comment or something. But let's see. So then we have like binding ref equals, or let's see, yeah, we look up the thing, we check if we have a binding type, and then we validate the type assignment. And here you can see that we actually also set the type assignment here, even though we do a validate type assignment. Now, I think the way, yeah, this is like properly done here. If we already had a type expression, we probably don't need to set the thing. So I'm just gonna do this. If it's not set, we will set it. But if it's not set, yeah, if it's not, if this is not set, then we set it down here. But if it is set, we don't need to set it again. And also, this will it could report like a type assignment error. So, yeah, okay, there we go. And we'll go back, restart the LSP. And now we should see, yeah, this expected that, and this is a my string. However, I would expect to see an error down here as well, though. So I don't know why we don't get an error down here. This is an int, this is a string. Not sure why that is. If we move this up, yeah, we don't get an error here. Is it because this is not like properly resolved or something? A second here. All right. So, okay, let's see. So, but we, okay, so we should get in here anyway, like, we should get a run assignment. Okay, well, now it's time to do the, log here, so, where is it? Here? Yeah. So let's see, go up here. So here we're doing this expression. Right, we're running this statement. We run the assignment. We run this expression. Should be fine. We materialize the thing. Now in here there should be an error. Not sure why it's not an error. Also, it's not really showing how we validate. It's not validating. So we do get down here, right? But then it fails or something. Or it doesn't do anything. Maybe we don't have a type, well no, we should have a type expression. Oh, we resolve the type on the expression. The expression is an identifier, right? So let's go to here. and we're doing a lookup on the name. And we get that. Which it should be an identifier, right? I think. And then let's see. Yeah, so this should be an identifier. We look up the name of the thing that's supposed to be assigned to. This should also have a binding, so we should get in here. But it's not logging out, so something does not happen here. I'm gonna log here. No, this is the assignment. Assignment type expression not found, or not, or it's null. That's just a straight up error. So this, okay, so either this is not, no, this should be, I think this is what's happening because we're not seeing anything else happen. Yeah, assignment type expression is null. Oh, this one as well, which does make sense. It's the same kind of thing. Okay, and then that's why it goes aborts the thing. Okay, why is it null though? Let's add a log here, maybe. I'll do this. Resolve expression type. Just a little convenience function here, so we can log things. We need the scope, and we need the expression. Although it, no. And we will get a maybe type expression. Right, so we will basically return this. Oops. And then I also want to add the logs. And now we can do self. So try resolve expression type. check if we have more of these. I'm gonna rename you to type expression so we don't get confused. You. We also want to do self-resolve expression type. Hang on. You're not actually a thing though. Okay, let's just put any type here then. This would be self-resolve expression type binding declaration initializer. Oh. Okay. Now we got some more here. Wow, there was a lot of these, actually. Or more than I remembered. Just need to make sure that the scope is correct that we send in here. No. Wait. Okay, well, the compiler's gonna complain if there's an issue. Okay, I think this is the last one. Otherwise, everything is like type expression. Yeah, this is wrong, I think. No, it's not. Okay. This is the only one left, I think. Yeah. Hello, Not Slider. Welcome back. I'm doing very well, thank you. How about yourself? Alright, now we got logs on all of those resolve type stuff. So we can potentially get some more debugging information there. Why are we not like seeing these errors? there we go. Resolve expression type. Expression span is not a function. Ah, yeah, that's right. We need to like get the span. Yeah, so basically, if has function or method, I guess. Yeah, sure. If type of expression has span, we will return that. I'm just gonna check if this does this check like pointers. Okay, it does check. Oh, okay, nice. Very nice. Okay, so yeah, if we have the span function, we call it. Otherwise, we try to get the span field, and that should be the span there. Okay. Awesome. So now we potentially should get more logs here. So we're resolving some type. Okay, we get the log. But we don't really have any more information on it. So, alright, cool, Slider. What have you been up to? So, I want to yeah, let's log a couple of things. Let's log the type name. Type name. What else could we actually log here? I'm not sure. I guess that if it's an expression, we could also try to do the tag name as well. So yeah, so basically, could we? Is there a way to check? I mean, I know there's a way to check if it's an enum or something, but so we could do tag is equal to if type info type of expression. Well, okay, this is very, I mean, we could also try to get, you know, because all of these should be structs, but does it work on pointers? It doesn't look like it. Okay. Just chilling today. Public holiday in my state. Oh, nice. What is the holiday called? Just curious. We kind of celebrated. It's not really a holiday, but it's like a common celebration we have. But it's actually celebrated on the 13th. But we had a little, because it landed on a weekend, so we had a little thing on birthday of the Sultan. Oh, okay. All right. Cool, cool. Let's see. Fields. I wish we had one for birthday of. I don't think we have anything like that. No, I don't think so. Let's see. Fields, expression. Okay, what are we trying to do here? So this doesn't work here. Okay, so let's just do the weird thing. Let's do like if type of expression is equal to an expression, then we do the tag name of expression. Otherwise, we'll do the type name of expression, or of the type of expression. Actually, we can also say like I mean, you could also do like some kind of you know, get is enum or is union or something. Which gets a type, and we return what do we return? We just need to know if it's an enum actually. Then we return the bool, and yeah, we'll just return like switch type of, or type info type of t, and if it's a union, I'm pretty sure you have to do this. If it's a union, we will return true. If it's a pointer, we will get that and return is union child. I mean, yeah, this would kind of be weird if you have like multi-staged pointers, which we never have basically, but okay, whatever, it doesn't matter now. Yeah. So now we can say, instead of doing this, we can say is union. It's not a type, so I will do this. If type of expression is a union, we use the tag name. I will also take the type name of the type of expression. You know what? Let's just store the type in T. So that we don't have to, yeah, we have a bunch of places where we need to. Oops. Tag name, yeah, that one. There we go. So S. Wait, label? Oh, I thought we had like a format function. Okay. But we can just add the tag here. I guess we can call this like type info or something. Okay. So, yeah, okay, there we go. Now let's see here. What is this now? Switch must handle all possibilities. 1 second here. All right. Let's see. Must what is that? Oh yeah. If we have anything else, we will return false. There we go. Expected unit were found. Oh, right. Okay, well. I mean, okay, can we use like active tag instead? Does this do anything? No, it doesn't. Okay. Well, it gets the tag, I guess, but it will no. I guess all of them are. You can see that all of them are like pointers. So basically, if we do this, it should just work, right? No, no, they are okay. So they are not all functions or pointers. But basically, okay. Let's just add this for its pointer. And I'll just do is pointer t. So if is pointer, we will do expression dereference, and otherwise we'll do that. Incompatible types. Oh. Okay, so let's what if we have it outside? Will that work? And then we do like tag name here, else tag name this. Will that work? Expect. Let's do this. This is starting to get a little bit crazy here. If we have this, we're gonna break this out. Tag name. Okay, that's the tag name. Maybe we can do comp time. It should be, everything here should be comp time. I'll just do it to make sure. And then here, I think this would be, if it's not a union, we will break this only. Okay, there we go. I think. Right. I'll just add a new line here. Okay. Result type, the type is an expression. Okay, so why don't we see the tag type here though? because this is a union enum. So we get that. That should be a pointer of the union. That should be a pointer to a union enum. Is union is supposed to be true if it's a union or if it's a pointer and we check the child. So it should be true. And then we should get some kind of tag name. So that's strange. Hello, Penguin. All right. I'll add this here. If t is equal to expression, we'll do a compiler error saying why is t not or why is t here? Is union false, of course, but why? Pointer child, and then this would be type name. And what is this? Expression. Okay. And is that a union? The answer should be yes. No, wait. Type is union. Oh yeah. There we go. It's not. Okay, so what is it? Type info of the child, and we do T for tag. It's a union. What the? Oh, I'm saying type of T, which is already a type. Actually, what is type of T? Type. Type info. It's a type. It's a void. Okay. Okay, good. So yeah, it's not type of T, it's just T. There we go. And same thing here. That might be no. Well, okay. Unable to resolve comp time expression. Okay, well, let's remove comp time, I guess. Okay. So yeah, it's sometimes a little bit tricky with this comp time stuff. So I think what's happening here is basically when you're in comp time context, some of the if statements, the compiler actually goes into each branch, even though you know, this is a comp time known statement. So I would think that wouldn't go in here if it's not a pointer, right? So oh wait, this is a different issue. It's saying that this is a union even though they are not actually. Also, why is it like pointer expression here though? Is pointer true? Yes. That's strange. God damn it. How can we fix this? Yeah, I can't think straight right now. Let's see. What is going on? Is union I mean, okay, I guess we could do this as well. We could do like a switch on. Yeah, let's just do this instead. Let's do switch on T, type of T, type info T. If it's a pointer, we grab the pointer and we say switch on type info P dot child. And now if you are a union, then we will say break with type name T plus dot and tag name of expression dereferenced. But if it's a union down here, we don't do that. And if it's not a union at all, we will just break with this. And now we don't really need a break at all. We can just do this actually. Oops. This one, right? Right, this is not a comp time value. Okay. Alright, so right, that's not a comp time value. Right, makes sense. Well, we could just make a allocating point or allocating rider here. Sure, why not? I kind of like this allocating rider. So it's pretty easy to work with. I just need an allocator, initialize, and here we can say alloc rider print, and here we can do S or actually T of this. And then let's do try here as well. And then yeah, you would be like writer print. There we go. And what else do we want? Actually, you are not that now. Alloc writer, write all this. Here is the same as this one. We don't do reference. Here is the same as this one. Okay, did we get there? The only thing we don't have is this one now. So actually, let's do alloc writer try and then print, or actually write all. At source function name plus that, and then down here we will do alloc writer. No, we already have the thing, so here we just say alloc writer written. There we go. There we go. We got there. We just had to do some runtime stuff. Okay. Okay, all in the name of debugging debug logs here. So let's see what we got. Pipeline. Cool. And a pipeline. Okay, well that's okay. So that is the. I see. So that is like the expression kind of the expression tag, yeah, and it makes sense because I don't think we've actually implemented the resolve type for pipeline. So I'm gonna go here and I will implement this now. So we're gonna have the pipeline, we're gonna have the scope, we probably need this as well. All right, so this is gonna be, first I'm gonna mimic kind of the execution here. So if stages length or self stages length is equal to 1, and the only stage if this is a command, it's always a command basically, but yeah, I guess we'll switch on the command. No, on the payload. And I guess we can handle both of them. So if it's an expression, we will return expression resolve type, allocator scope, what's it called, expression, yeah. And then we will do command. Now the command, we need to check now if the command args length is 0. Now we need to treat this basically like an identifier that we need to look up. Now I think this will kind of change actually. It's kind of weird, like this I think we're gonna change how this works later. If you just have an identifier in an expression, we're kind of now we're parsing it as a pipeline with one stage and no arguments, and then we do kind of like an unwrap of that to get to the actual value inside. But it could be, because it could be just a command that you wanna call. And before we didn't have any semantic analysis, but now we do have semantic analysis. So now we could probably get rid of this whole thing actually. So when we parse, we should now return an identifier, not a pipeline. And then the type checker will actually resolve the type into something like into either, the type of the identifier, or, maybe like a pipeline with one stage and a thing. So, yeah. But yeah, let's not do that right now. Let's just go with this here. So we should have then a name. Now we do need to like look up this name here, because if this has arguments, then it's it could be a function. Actually, you know what? Let's just do a lookup here. We need to be able to get this name though. Man, why is this so convoluted? Okay. I mean, we don't really have a way to like properly do this with this string literal here. These expressions need to be resolved into an identifier that we then, this doesn't really work. I'm just gonna support the word now, because I think that's the only thing we have actually. So command name word. The other ones are gonna basically return some kind of error, I think. This is gonna be like I don't know, some kind of scope error. Welcome back, Penguin. If we have a word, and the word is just something, please. Text. Okay. Right. And if we have a word, I know this is horribly nested here, but whatever. This is highly temporary anyway. If we have a word, then we want to now do a lookup. So this would be like some kind of binding that we might get from the scope. Now we can do a lookup with word.text. Okay, and then we maybe get a binding. If we don't get a binding, we wanna, what do we wanna do? I guess we have to do like a failed thing. Return failed. Yeah. I actually want to see if we can make this work here. We have this failed type. I'm gonna say, can we make a failed thing here that is, no, not self, it's gonna have allocator, and we're gonna return a type expression. Right, does this work? So first we're gonna get the type expression container, which is allocator create type expression. Oops, we're gonna return that. and you're gonna be try there. And then type expression is equal to failed. No. I guess we need the span as well. But is this shadowing here? Yeah, it's shadowing. Okay. I guess alloc failed. We could call this. Now, can we get this from there? No, we can't. So, but we can do type expression alloc failed. Well, shadows, declaration of span. That doesn't sound right. What? How does this? We don't have a span on type expression. Type expression is a union. Am I missing something here? Why is this happening? I have no idea. Maybe there's something. Maybe there's like an uneven number of these. Not sure. Anyway, we need to provide the span, so the span would be this, I guess. No. Well, yes, it's that. Yeah, it is that. That's so weird. Like, what do you mean? There's nothing called span here. Okay, let's just continue here to see if we can solve the issue. Okay, so if we have a binding, that means we should have a type expression on there. So we just return that. Okay. If we have anything else, we will. I'm just gonna return self. Or failed here. Let's do return there. And there. And also here. The span is going to be the whole thing. Okay. Else prong unreachable. Oh, I see. Okay, so what's this? Which theme are you using? It's called Melange. I'm gonna type it out for you there. Or yeah, the color scheme. Why is this happening? I don't understand. That's super strange. Oh, because of this? Because we have a function called span. Oh. Okay, whatever, let's just do this. Error set ignored. Identifier already declared out of memory, type not found. I guess we'll do type not found. Actually, let's just do failed there. Yeah, let's just do failed as well. And okay. Seems to have. Right, there we go. Now we get a bunch of errors. Okay, okay. So now it's a, and now it's, oh, we get here as well now. Interesting. Why do we get here? That's a bug. Expected int actual my string. Okay, the report is wrong. What? This is like the only thing that's correct. Why would D be my string? That is strange. Let's see what the reporters are saying. So this one should be correct here, yeah. Now we're doing this one. And we're doing an assignment. We're running this. We are resolving the pipeline, which resolved into something. Should we show the result of the resolve as well? That makes sense to me. So we can follow along everything that's happening. So let's get this result. Return it. Oh, excuse me. And we can log out. Let's log without prefix. And we'll say result is, I guess it would be like the tag name of the results. It's a question mark. Actually, we have a format function. Cannot print error union. Oh, I guess we'll do try. Okay, result is an int. Very good. Result is an int, and then we try to materialize the binding type. So I think here I would want to say also materialize binding type. Let's do the name of the identifier. And then if we get a type expression, we want to show that here. Or F. Oh, but it's actually let's just do like question mark here to denote that we don't know what it is. Yeah. And we return. Otherwise, we do that. Okay, let's just see if this works. Materials binding type, identifier, my string. Yeah, cool. And then we get the lookup here, which has to exist at this point. If the binding had a type expression already. Hang on, no, this is the assignment. Right, this is the assignment. Okay. So we'll do assignment type is equal to whatever that is. Okay, and here we can log, now we can log like the binding type. I mean, we could actually log the binding type here. Yeah, actually we could just log the binding type directly here. So question mark format, binding type expression. Okay. And then we do assignment type. Oops. And yeah. Oh wait, we don't have the binding ref here. God damn it. Okay, whatever. I'll move this down. Assignment type is that. We need a new line. Now we can do the log binding type is equal to that. Okay. Right, so we're trying to, so identifier D is binding type is int, which makes sense here. We're binding it to an int, so the binding type is int, so it's already an int. And then the assignment type is my string, so that should be an assignment error. But there seems to be something wrong with the report here, because we're getting the error here, which is not the where the error should be. It should be like, we get the error at like the binding type location, not at the assignment type location. So where is that happening? Also, we get like the we get like the wrong message as well. It's like they are flipped here. What is it? Report assignment error. So we get expected, actual, and then options. Expected binding, actual is assignment. That makes sense. Assignment alias actual. That makes sense. This all makes sense. Binding, assignment, expected, actual. Yes. So we have to check like everywhere if the order is correct. should be, but you know, you never know. Okay, it seems to be. Okay. So this one is probably the one we take from. This is the binding type. It's an integer. We report an error if it's not an integer, and we provide the assignment type. Oh, I see. I think I know what's going on. Maybe. Perhaps. Or perhaps not. Report span error, expected type in actual my string. So this is this one. I think, yeah, that's also flipped, I think. See, this makes sense. The assignment type is int, binding type my string, identifier b. Identifier b is the one being assigned to. D is the one that's being assigned, or the expression that is being assigned. And, or, yeah, the assignment expression, which is type int, makes sense, binding is my string. So then we report this error, I think. We report this assignment error, expected my string actual int, which makes sense. That's the correct error. However, I think the span is wrong. I think it's like reporting it in the incorrect place. The span is wrong. We're reporting in this span here. So let's check the spans. Assignment type span. So that would be like the original place where the assignment type is. Yeah, I think that's what's wrong here. I guess we would just use... This is kind of weird because this error type is not necessarily the place either. The place should be the assignment place. So actually we need to have like the actual assignment, the original assignment expression here. Or like original span, I guess. This would be like the original span. Yeah, that's way more generic. Because then we could just use that span. We don't actually need to pass in a span in the report function, because I think we already send in the options. No, not span. Report assignment error. There we go. Yeah, we don't actually need to pass in this. Okay. And we don't get the span. What we do is we say option span here instead. There we go. Okay, but now you need a span apparently. The span, I mean, I guess it would be like the name. No, it wouldn't. We need to pass in a span here. The span would be assignment span. There we go. That was it. Yeah, this is only, I guess this is only function calling it, so cool. Okay, there we go. Now it's like the whole thing. So expected type myString actual int. I mean, technically you would want this to be the span, I guess. I mean, it's easily, I actually easily changed. We can do assignment expression span instead. There we go. There we go. Here we expect myString actual int. Here we expect myString actual int. And here we expect an int actual myString. There we go. We got there. Alright, so let's go to our LSP now, see if we get these. There we go. Awesome. Okay, so yeah, the fix was a little bit more involved than I thought, but yeah, cool. We got it fixed. So this is now, well, okay, we fixed this, but we also fixed, I guess we also fixed assignment errors not being reported. Okay, yeah. Then let's see, for pipelines, I guess you could say, for pipelines. So okay, actually what we did was we implemented result types for pipelines that are actually just identifiers. That's what we did. Okay. Now, this one, we want to find a scope. So okay, let me just show to explain here. So basically, when we do this hover lookup, we get like the original, you know, we look at the identifier that we're on, and we're doing a lookup in the scope that we're in, or trying to anyway. However, it only works right now for the topmost scope. It doesn't work in here. No information available. Because now we're an inner scope, and this doesn't work. So we actually need to upgrade our scope finding function to be able to find the inner scopes as well, depending on like the position you put there. So let's go do that. Yeah, I think type checker has it somewhere. Get scope from location. Here you are. Yeah. All right, right now we just return the top scope. But we need to find the inner scope based on the location that we're given. And there's kind of like a naive, easy way to do it, because I have a bunch of convenient stuff for these, but it's probably not going to be super fast. Well, basically, the module, which is the scope, has a bunch of children. It's a tree, basically. So we can go ahead and go through all the children recursively, and try to find the scope in there. So basically, if we go through all of these children, oops, we got child, and we have a span, I think, or not. Okay, so we don't have a span, but we should implement that actually. So Okay, yeah, this is where, okay, this is probably the hardest part here. We actually need to add a span to the scope. But the issue is, what is the span? Or maybe it's not that big of an issue actually. But let's just see here. Span. Yeah. As if, let's say we do have the span. Now we can just use the span and check if it contains the location of this location. And if it does, then we will return, or wait, if this is true, we will return the child. So that would be, no, actually, we need to, okay, it's not that simple actually. We need to look at this child's children as well. And then we'll need to find the deepest nested scope that we can find. Now, presumably, if you have a parent, the child should always be contained in the parent. So I would assume, like, if the parent contains the child, or yeah, if the child if we contain it in the child, there's not going to be another child that has the like overlapping scope here. So I'm gonna say, let's have, either we can do this recursively. Let's just do it recursively. So get scope from location. I'm just gonna do like an aux function here. And we don't even need self, I don't think. We need location. And we need the let's get one scope. And first we'll check if scope span contains location. Then we'll go through. If it doesn't, we have to return null. Otherwise, we'll return for scope children items child. Get scope child. So, okay, and then here we'll just call get scope location module. If it's null, we'll just return module itself. Fine. So it shouldn't be. We should always get something, but you know. But does this get us the deepest one though? I think so, because we try to look at the thing that did contain it. If we found one that did contain, no, this won't work. We need to like, let's do this. Because the thing is like, okay, we're checking if this locate, then we return null. Okay, fine. Then we're going through all the children. If we find one in one of these, we need to return that. Found. Return found. Otherwise, we continue. Go through every child. Right? So we'll abort the whole thing. This will abort the whole thing if we found a child that contained the location. Right? Isn't that true? Like, it will go through the child, it will check if it's contain. If it didn't contain, we return null. So we found at least one child that contains. Actually, no, we're not done. Because then, let's say there's no children, for example. So if there's no children, we should get out here. If we get out here, I guess we still contain the location, so we could just return the scope itself, actually. So that would mean we were the deepest scope in where we actually found a match. Yeah, I think that should work. What's this? Okay, so now the only thing is, like, we need to find, or we need to we need to basically create these spans here now. So this span would be the first span. This would be the whole file. This is like the grandparent here. And here's the script. So actually, let's put this below, because we need the script, because the script has the span. The script has the span in it. There we go. That's the whole thing. This global scope creates a child which now needs a span as well. And you need a span, but this is just gonna be the parent scope's span. So I'm just gonna copy that. Okay. Now, we have a couple of places we need to fix. All the places that creates new scopes, basically. All the blocks places. So this block, run block in new scope, this is just going to be the block span. Easy peasy. That's the block span. Okay, function. Yeah, that's just going to be the whole function span, I think. Because if you want to know the parameters, they are defined in the function in this scope. Yeah. So they should be part of that. Yeah. And let's see. For scope, we have for expression span. And if something is weird, we'll notice it and fix it. And this is just if expression span, I think. Yeah. Okay. Actually, let me see. All right. So let's see if it. Okay, this still works. Does this work? Hey, yeah, it works. Okay, let's actually see now if I say in inner scope, no information. Okay, that actually, but that does make sense because this is in the inner scope, so it wouldn't be available. But what if we have the outer scope? This is still available. Oh my god, it just works. Awesome. All right, I have 2.5 hours left, just about. Cool. All right, so now we can do that. Cool. That was actually a lot easier than I thought. I mean, fast reverse lookup, this is not really what we have. We have like scope lookup on based on location. Cool. Okay, what do we want to do now? We kind of exited the chapter there a little bit with the LSP hover information. Where did I put that? So this works now. I mean, we do, well, we have hover implementation identified hookup. I mean, if we try to, let's say if we make a function, for example, actually we should try all those different blocks. So the basic block works. Well, let's make a function. Hello string. Okay, it crashed. Why did it crash now? The LSP crashed for some reason. Invalidate document. Okay. Segfault. All right. So we get this did change thing, and then we're trying to print the new document. And at each change, we are also rerunning the type checker. And in the process of doing that, we are trying to invalidate the document, which involves doing some stuff. So let's check that. What else can we get from here? We're trying to do an equal bytes. I see. Let's check the order of operations here. So LSP document, I think. All right. So we invalidate the document of the type checker. So we remove it from, well, this is like it's a hash map from path to a scope, and like the main scope of the module. And then we remove the diagnostics as well. We also, okay, so I think it's this part where it fails, probably. Span start file. I don't think it matters the order here. Shouldn't matter. Okay, I just need to BRB 1 second. BRB. All right, I'm back. So, where are we? Oh yeah, this issue here. Okay, so which is causing the issue though? The A, I think. This should be the left one, right? So this one, the diagnostic. I mean, okay, so basically we do like a swap remove, which would move the last in the place where we are currently. That should be the same index where we are, and then we just continue and we grab out that and check now. Oh, I see. Wait. No, but then it should also check the length at the same time, right? So this should never be like invalid, as far as I can understand. Yeah, let's say we are on the last item. So I is length -1. We grab that item. We're checking on it. We do a swap remove. We continue. The swap remove should change the length to -1. Now I is actually... Now we should just quit that. Right? Or if we are not on the last... We grab the current item, we check if it's a path, we remove it, and then we don't change I because now we need to check the current item as well, because it's been swapped from the end to here. It's not like... I don't think there's an issue with the valid document per se. I mean, we had a bunch of these things happening before and it wasn't a problem. And, well, what about this data though? It's either an expression or a span. You know what? Let's just remove the expression one, because I think we don't really need that. Let's just change this to span. Yeah, there's no data here. We only use the span. Yeah. Well, this actually has to be named like this, and then this would return self.span. Alright, now you will be that. No, that. Iterate backwards. Yeah, I guess we can do that as well. Yeah. I don't see any problem with the algorithm though. Although it's, I guess it could be more, maybe like readable. I mean, it's not that complicated though, but wait, is that it? We didn't actually use the other one. Okay. So report expression error. Where is that? Oh, did we remove that? Okay. So we didn't even use the other one. Cool. Yeah, this still works. Now let's try and write this again here. Okay, well, we didn't get a crash this time, but I'm not sure if the problem is fixed or what. Hello, Dev Ninja. Welcome. How's it going? All right. Yeah, okay, so let's say I'm not sure if we don't have parameters yet, I don't think. No. Although string should say something. String should be available. Oh, now we don't get any information at all. Has it gone haywire? No. Okay, so there's something with this that doesn't work. Okay, maybe it's parsing. Maybe it's a parsing error. Yeah, great. I'm doing fine. No, I'm using 0.15. I don't like using like unstable versions. So I'm gonna wait until it's done. But it's gonna get interesting. I haven't looked at any of how it works or anything. I'm just gonna wait until they stabilize it and look at it then. What is going on here? Parse scripts, compile result. What the hell? It just gives up. Wait, so how do we get these now? I am confused. Okay, there might be something weird going on with the log, with the parse logger, the parser logger. So let's check it out. I mean, we are flushing. If you don't like unstable works on outcome, you use a software which is pre 1.0. I mean, yeah, good point. But I mean, it is stable enough to work actually pretty well. So I haven't found any issues that are like showstoppers or anything. I have found a couple of issues with the compiler, but it's not many. Like, it works very well for, I guess, I don't know, an unreleased or unfinished product. Just like my language. No, I'm just kidding. Okay, why is this happening? So basically, okay, skipping token. You can see this weird number here. Maybe it's time to fix this issue, because this might be part of the issue. What are we getting from... Also, why is this like this? Why are you like this? Print tokens. Okay, so we do get a bunch of tokens. I don't see anything weird with the tokens. The tokens looks fine. So I have no idea what this is about. Let's check it out. Parse script inner. Are you a Zig developer as well, Dev Ninja? Okay, so basically we get this breadcrumb, right? Then we're trying to get the AST. Right, so if we already, it's basically if we already have the AST, we bring it, we bring you the cached AST. But we should, I mean, in order to get the AST, it has to be created first, which is not happening really. I tried to take my own language, but this is for Rust. Maybe I'm rewriting it in Odin. Why? Isn't Rust good enough? Why did you ditch Zig? And which version did you use? And yeah, let's see. Well, okay, so parse it. So we don't even get here. I don't. Well, or do we actually? No, we don't even get to compile result. Or I mean, we get to compile result, but we don't get here. So where is it exiting here? It's not exiting here. It could exit here, but I don't think so because we don't have an AST yet. I guess we could log here. We could log I'm gonna implement this. Yeah, basically that. I know scopes, lifetimes, or sucker even the compilers, but compilers got way better since I tried Rust last time. At first, 0.15 switch to 0.16 API would definitely break in multiple places for the standard. Okay, I see. Yeah, it's gonna break at some point anyway, but like, I don't know. I'm not sure how much it's gonna change in the future, but I'm just gonna say, okay, well, we're just gonna have to live with breaking changes for a while, basically. I just feel Zig is so much fun, so I don't really, yeah, to me it's not that big of a deal. And a way to, I guess, mitigate it a little bit is to make your own interface. However, it is kind of weird. Like, let's say, we're using this rider interface, right? So if they change this in a major way, how many places would you have to change? Because this kind of comp time format args pattern is basically everywhere. So, but yeah. That's what we have to live with when we're using, less than 1.0. I mean, actually, you would have to live with that anyway in any language. It's just that right now it's like a little bit more. You're always gonna get breaking changes. When you're starting out and you see new AI is coming, it doesn't make sense to not include it directly from the start. I mean, I think that I don't want to use 0.16 because it could potentially have a bunch of bugs that I don't want to deal with. So I just don't even want to look at it. And let's say 0.16 drops and now we have to change a bunch of places. Fine. I'm still, getting experience with the language and doing other stuff. It's not just the IO stuff. But yeah, it's gonna be interesting. It's also, they changed the IO stuff recently, like to these new interfaces as well. Like last version, wait, which version was it? Was it now 0.15 or 0.14? I don't remember. I think it was 0.15. So they're gonna change it like 2 times in a row, possibly. I mean, I don't know, actually. I don't know what, like the async away stuff, I'm not sure what exactly that will affect, if it will affect anything. I don't know. In any case, I would just have to update the code, so don't forget to flash. Yeah. Thank you. I flash here. And I don't like to have a defer flash because you can't have like defer try, but technically you might want to have defer, but I mean, if you can't write anyway, what's the point in flushing? I don't know. I also did sig for the weird way of doing strings. It's so uncommon to not have an abstraction for that, like UTF-8 for example. Even Odin has byte, car, rune and string. Okay. Well, I don't really deal with like UTF-8, so it hasn't really been a problem for me yet. We'll see though. Is there a UTF? No. There's like ASCII library. That's all I need. Let's see, loginal prefix. Okay, so what do we want to do? We want to just log out that we are returning the cached AST. So then at least we know that we're doing that, and we're not, unless we didn't build properly. Okay. Did you try using emojis as variables names? Why would I do that? No, I don't do that. And I don't care if I can't have emojis in my variable names or my comments. I'm not trying to paste images either into the code. Yeah, it's just not a feature that I care about, so it doesn't matter to me. All right. Returning cached AST. Yeah, so that doesn't happen. So where are we exiting? Like, if we get an error, it should be reported. It could be swallowed up, I guess. We got the source, probably. We create the stream. No, because we never get here. Because that immediately logs out. Okay, let's just do some logging here. Log debugging. Got source. Created stream. Nothing. As you, I think you should implement what you need from the old writer on top of the new one. Keep most of the code as is. Yeah, I mean the problem is basically also like even if I would have an abstraction, right? It would adhere to this pattern of having like I don't know what how the new system looks. But let's say they change it drastically, so you no longer have like comp time format string or args any type. They change that. Now I have to basically go around, fix that pattern. Probably, I'm not sure, but I mean, sure, I can write an interface that is like adapting the old one to the new one, and maybe they will even add one that makes it easier to get the new version without like. Usually they have like a deprecated version of the new thing that you can use. But yeah, that's what I mean. Like this pattern is basically everywhere now, and I don't see like. I mean, sure, it should probably work. You know, probably you have to go into print and do like async await or something like that. Sure. I guess that's what we could do. We could even, I'm using like this interface everywhere, so I could just replace that, create an interface that works with the old way of doing things, and just use that everywhere. But I'm not even gonna think about that right now. It's not really a huge deal. I just need to change how things work. I mean, I would rather do it the new way than to keep the old way of doing it. But right now I don't have access to it, and I don't want to switch versions yet. I'm waiting for the release. To me, it's not, you know, it's not much difference between waiting a little bit longer and doing it now. Because I don't want to deal with potential other issues. I've seen the milestone. There's still like a bunch of bugs and stuff, and I just don't want to, you know, I just don't want to think about it. Okay. Anyway, why are we not logging anything? Does it not do this either? Where is, so this is called from parse script, and we catch null. Okay, well, I guess what we'll do is we will catch the error, and we will return null, but we will also log out error. Okay. God damn it. Oh, I see. Let's just catch there then. Oh, I see. Wait, but I'm not return null. Okay, so let's do break. There we go. There we go. We got there, I think. Yeah. Let's do build. Oh, we got some errors somewhere here. Expected tuple struct argument from imprint. Ah, right here. Speaking of interfaces. Okay. Right failed. What? Right failed? Okay. Why do we get the right failed? We have had this problem before. This, I mean, this works. Also, skipping token, like it does go in and it's starting to do things. So that's skipping token. Is this the who is printing this? Is it me or is it the writer? No, they can't be. Here it is. I see, I see. Current line. So we always get like a token. And we're skipping. Wait. So if the length is 1 and it's a new line, we log that. Why does it say skipping here? I guess if the token is like not the same line, I guess. Okay. Skipping token, start line, end line. lexeme. What is the lexeme? It's like nothing. Why do we have a token that's nothing? I wanna add a length here. It might be empty, perhaps. It's not. It's quite large. What the hell? Okay, that might be why we get a write fail here. Just a hunch. We're trying to write a string that's what is this? 1,000, million, billion, trillion, whatever. Yeah, it's a large string. And I guess we will have some kind of maximum value here. I'm just gonna say like to 10, or well, let's do like 32. Well, if the length is more than 32, we'll print this at the end. Okay. So what is happening? Stream current. Oh, that's not, that doesn't exist yet though. How is this set to something? Okay, there is a weird bug here then. This is like filled with some kind of garbage. This one should be, you know, empty. And yeah, you just return the next one. And yeah, I mean, it's just the tokens. Like when we log the tokens, there's nothing, I don't see anything wrong with that. That's what's so strange about this. Okay, I guess if, okay, I guess we could do this, like if the token has a length that is more than, I don't know, invalid. Well, I guess we could look at the characters. We could look at like, what is the character a valid character? So let's use ASCII. Is print, I think it's printable, right? So if it's printable, we will try to print it. If it's not printable, we will say invalid. Now, yeah, this only checks the first one, but we still get some issues here. Oh, I see. Okay, so that this whole thing is invalid. Let's do. Okay, I'm gonna guess this is gonna be set to OXAAAAAAAA. Ah, it's not printing it out. Okay, we have to like. I'm gonna do that for now. Okay. Well, we get the whole AST thing here. Skipping token. It's 0. Why is the length? Like, why is it invalid? Okay, well, if all right. Very strange. Very strange that we get this token here. And it's before these, so it's probably the same as it's probably created here, like when we have create the thing here. But the problem is that we don't really have, it shouldn't even have a current token at that point. The stream, oh my god, it's undefined. Okay, well that okay. Where is the stream set? Oh, it's set here. Oh my god, okay. Oh, because we need the source. Let's do. We'll take that, put it over here. Are we done? Actually, put it over here. And there we go. Okay. Oh my god. That was way too much debugging for that little mistake. Okay. Right. So now we should have the parser. Okay, cool. Let's go back to the type checker now. What did I call it? Type check only. Cool. And okay, let's go back to the file. Okay, let's try create a function. Okay, there we go. Wow. Okay. And as you can see, this works. This expression here is like formatted from the type expression. So it just takes whatever format function we have for that. Let's see if, however, I don't think this will work though, because I don't think we are. Yeah, now it's like failing again. Sent result markdown value empty. Yeah, now we don't get anything because presumably the parser fails or something. Okay, yeah, we don't get anything here. Print parser, no, AST. Do we get tokens? Yeah, we get tokens. And then if we log the parser, yeah. So basically, the kind of the parser, when it encounters an error, right now it's kind of like in progress. That what we're like implementing for the parser. The parser is supposed to spit out some kind of AST, even if it fails the parser in some place. And that work is still in progress. Like before, we just exited the whole thing and you just get a parse error and you have to fix it before you can get any more diagnostics. I'm trying to make it so that even if parsing fails, we can still get an AST that we can type check to get some information, or get some hover information or scope information and stuff like that. So right now we have to kind of fix some of these issues that the parser, and as you can see, it does parse a bunch of things, or tries to anyway, but then when we get to wherever we are over here, it fails here because it gets like unexpected tokens. So I think it's because we don't really have parameter parsing. So let's just add that actually. I'll add parameter parsing instead of ignoring it, I guess. Or we could go to like parse function. So parameters, right? Yeah, nothing's happening here. We could also just skip until the right parentheses. Let's just do the parentheses, or the params, I mean. So the params basically gonna be parse list, delimiter is a comma, parser is parse parameter, what is this, types? Okay, let's remove that. Yeah, and then we also want to have like a lambda version, but or yeah, expression function type. But right now we only have like block types or block functions. So we need like parse parameter or parse param. Let's call it param. And this would give us an error or a... What would it give us actually? Parameter? Yeah. Because you want a bunch of parameters. There we go. And once we have it, we can just chuck it in here. Params. Payload. Alright. Yo, Bar Checker, welcome back. How you doing? Let's see, I've got about like 1 hour left here. Alright, so what's the parameter? The parameter... You found Zig's anonymous structs a little weird? How so? The only thing I find weird about them, I guess, would be the type. I wish it worked like in TypeScript, where if you have a structure that has the same fields, the same types and everything, they could be interchangeably used. Especially if it's an anonymous struct, because those should have the same, you know, other metadata around it. There's things like alignment and stuff like that, but dot assumes name designated, a name designated in it is point, but they don't do it like that. Yeah, so basically, in order for this to resolve into the type you want, okay, so what's happening here? It's basically if you know the result type of the struct, it will get that type. Here, the result type is this, because that's the return type. That's why this is not really anonymous, actually. This is not anonymous. This is actually this, because it's gonna resolve into that. But if you didn't know the type, you would get, you know, you would get like a generated struct type that's an anonymous struct type. Point. If each field is accessed using dot prefix with a name point, looks more like point AB. Well, I don't understand. It would have made more sense to use dot braces as normal designator without each field needing dot prefix. Oh, camel style. Okay. So how would that look? I don't know. To me, it's like dot something just means like in the context of this struct literal, I guess you could call this struct literal expression. The dot is just saying that I want to set this field to some value. The dot before brace marks the field access of the initializer. Yeah, so this to me also, like the dot before the braces, it kind of means that this is like a wild card almost. This is like, yeah, or not a wild card, but it's like a replacement for the actual identifier that is the structure that you that is the result. So, you know, it's kind of replacing that, but instead of having to write that out, we just use dot, because otherwise you would have a kind of a block scope instead if you don't have the dot there. And also it makes sense, you know, usually you want to create a new struct, you always put a dot. You have a dot, or you use the type name, but you basically always have a dot right now, because you don't really need the type name anymore, because if you know the result, you just do dot init, for example, which makes a lot of sense for me. This also allows consistent unnamed name initializer. Name dot field equals value dot field equals value. Okay. Well, yeah, I mean, the dot thing is like, I haven't got used to that because I never used a language that has this. I know other languages also has like dot on the fields and stuff. To me, it's like this could just as well be the syntax. It doesn't really, I mean, it doesn't really bother me that much, and I guess it's just a choice of the language. It doesn't really feel like it's blocking any. Came from C99. Okay. Yeah, it was kind of weird at the start, but you know, I got used to it, and it doesn't really, you know, it doesn't really matter that much to me. Since I like the language otherwise. Or, I mean, I don't mind the dots, to be honest. Oh, you need a, wait. You want to have that, you found this. Okay, well, let's just change you to be that. No, it's not const pointers, actually that. But now it's a constant array. This array should be stored in the arena, right? Yeah, it's not const actually. I don't think. We're copying it. Why does this produce a const? It shouldn't produce a const t. Expected found that. Yes. But would that, what does it matter? Like, you're the result. Like, if we decide you to be const, that shouldn't matter. I guess maybe it's because it's a pointer and it's, I don't know. It feels like we should be able to add const whenever we want, but not remove it. Okay, anyway, now there's no issues there. So, what is a parameter? A parameter is, first we have an identifier, and then we have maybe annotation. Okay. And No. Parameter is gonna be create parameter but I'm curious, like I don't really understand what the issue that you're talking about is. I'm just curious, like what is the what kind of expression is it not allowing you to have? Or are you saying that you want a dot after the identifier, like name dot, not just name and then braces? Is that what you're saying? Name brace is ambiguous. How? Name dot and dot are consistent. Name becomes optional. But how is it ambiguous? This aligns with how unnamed function just. Okay. But how is name without a dot ambiguous? I mean, I'm sure it is, but you have to explain it to me because I don't see it right now. Okay, now param needs to be populated. Parser needs to look up where. Needs to look up are we name, are we block that has dots in field equality operator, but in context of dot you can just, this is struct literal not a block because it always starts with a dot. Are we block that has dots in field? Okay, I see. Interesting. Can you actually have that? Yeah. I mean, is it ambiguous? Because if you have an identifier here, you can't just have an identifier and then a block starts. I'm not sure if it's actually ambiguous. A struct literal in zig separated by commas, not semis. Here you have to specify separate block parsing into different forms. Oh, you're saying that there's like different kinds of blocks. But you don't have to do that. I don't think if you find an identifier and then start with the braces, wouldn't you know that you're a struct literal? Like these two are kind of together in this expression, right? Or is this colliding with something else? I guess you could also have a function call. It depends on the context, and that's the problem. It's not context free. Okay, sure, but fine. It's not context free. I know that you talked about that earlier. It's not context free, but does that actually, you know, I mean, yeah, it makes the parser more complex. But what does it like? What's the other issues it could do? It could make happen. You make your language more complex by having context at all. See what C++ is going into. Okay, well, yeah. I think as long as you don't go into those rabbit holes, like for now, I think it's like, for me, it works pretty well. I'm not sure. I mean, the LSP doesn't really work with trying to fill this in here, but Zig is stable that they have a chance to improvise. Yeah, they should really, like, you know, these kinds of things, they should, if they want to have this like stable and reach a good stable parser and everything like that, they should do it now. I mean, they shouldn't think about backwards compatibility or anything like that right now. We talked about this a little bit before, like backwards compatibility shouldn't be like a thing right now. They should just, they shouldn't break the API. I mean, I don't think they should I don't think they should care about that, because it's like, it's supposed to be and you know, under development. There's no 1.0 or anything yet. So I hope that they will, in pursuit of making a really nice language, break whatever they want. They can already interrupt with C really well. Yes, they need to focus on the grammar stability. Alright. I mean, I don't really mind this. I guess it's more for like the inner workings of Zig, I guess. I've kind of gotten used to, you know, the whole struct literals things. Although I don't really see, I mean, some of the dot things make sense, and some of it is like, I mean, in here, let's say in this expression here, can we have anything else than field assignments? I don't think so, right? There's nothing in here that's not supposed to be a field assignment. The only thing you can have are field assignments. Isn't that correct? So why do we need a dot? Okay. Anyway, yeah. I just haven't thought about it that much. I was just like, I've just accepted that that's the way it is, and it's fine. It makes sense in some sort of sense, but they designed it around that context, yeah. If it were just dot, you wouldn't need a dot. Parser already knows does the structure knows. Yeah, that's exactly what I mean. Like, the only thing that this could be is a struct literal. So the only thing that could exist in here are field assignments. But name could be anything. You have to check if it's an identifier or keyword. Okay, sure, yeah, but you know, in effect, they know that this doesn't work. If it's a keyword, or I mean, if it's an identifier, or you know, some kind of expression like this. Actually, it what the hell? You can have any kind of expression here. It doesn't need to be only an identifier. It could be anything really. And then you have the block afterwards. I guess it depends on what this is. You can have like an if here. But then this block would be consumed as the if. It belongs to the if. Okay, anyway, the LSP doesn't work here, so oh yeah, the pattern, it's a pattern, that's right. Parse pattern. Type annotation, default value, mutable. Mutable is false. I'm just gonna say span is like start with the pattern and end at the end, which we don't know yet. So we might have an annotation, and then we might have a default value. And this is basically pick what is going on? Why? What is actually happening? Oh, it's pattern. Okay, there we go. If no picked if we get a token, if this is an equal or a sign, then we return try, well, then we consume it and we do try parse expression. Of course, this should be nullable and return null otherwise. Yeah, and then the end is going to be annotate. So end is annotations. Span else if actually it's we should start with default value. Else we could have an annotation. Or else it's gonna be the pattern. And we return this. There we go. Ignored, yes, we ignore you. Okay. Right, result typing parameter. I have a hard time typing parameter. Wait, there is parameter. There is a result type in parameter. What the hell? Oh wait, this is double now. Okay, there we go. There we go. Okay, good. Okay, cool. And we even get this. Yes! Sorry. Okay. And then we can have a default value as well. But that's not really used. But hey, at least we have it. Okay. What can we do now? Well, we don't really have we can't run this, I don't think. Well, of course we can't run it because there's like type errors down here. But even if we fix those, we can't run it. We got memory leaks, double free. Yeah. The executor has some issues. What if we remove the function? No? Should we hunt this now? Double free on RC. Interpreter scope 229. Declare value at 1246. So this is where we create, we bind the pattern, of course. Well, might be the parameter, perhaps. No, it's not, because we removed the function. So it's one of the strings. Oh, I'm not sure if it's this one though. Yeah, these. So let's try doing just strings. Okay, we still get double free. Is it the scope? The block? Yeah. What if we make a function? No? Okay, it's this block that causes it. For some reason. What is it? Evaluate expression, block expression. Right, we're pushing a new frame. We are running all the statements and deleting all the values. And we pop the frame, so it should get like deinitialized. Okay, let's just add the executor logger here. Oh, I see. It's the act of actually deinitializing the values for some reason. Okay. So maybe there's something wrong with the clone. Now we're just putting it in here. And we're declaring it, which moves it in there, which doesn't really do much at all. You just put the value in there. You actually create that as a pointer as well. Right, it's stored in the RC because it's mutable. Like if I'm changed this to be a const, I don't think we get the issue. No. If we have discard, we initialize. If we don't, we declare it. So that should move it in there. If something goes wrong, we initialize, but nothing goes wrong, it seems. So that shouldn't happen. Yeah, so this code is part of the like RC being released. And this also. So we got like 2 releases. And for some reason this fails. This shouldn't actually fail. Like the RC should keep track of how many. Yeah, it should keep track. if it's released or not. So let's inspect. No, it's gonna be the scope and the binding things. Wait. This creates a new ref. Yes, it does. But it's not even a ref, it just returns itself. Yeah, the inner value is not a ref. But this mutable thing is a ref. And this is getting called whenever we pop the scope. Okay. I don't even know where we ref it, to be honest. Do we even use this function? If we make a closure, we don't have a closure though. Okay, so this won't get called. So this is the only place. So declare closure, but we don't have a closure ref. Okay, so maybe something else is wrong then. Of course. No, I'm pretty sure it was the binding. Mutable? Yeah. It's the mutable binding value, or yeah, the mutable binding. Actually, no, this is the. No, yeah. No, that's fine. That's right. And then you go in and you create the actual value pointer inside. That's right, and that's what's getting freed twice. This gets released from somewhere. I wish they would show more of the stack trace. Why are they only showing so little? Maybe there's a way to increase that. Like, is there a way if we go to main? Wait, what? Okay, I see. So its safety is around trace stack frames, debug default 6. Okay. So we can increase this. use size. Okay. So let's, I don't know, 12. $24. There we go. Yeah. Binding. First free. Comes from single ref or single yeah, pop the frame, evaluate to 218. So the block is done, we pop the frame. Okay, so that presumably is done first. Where's the second free? Over here. Same. What? Huh? Hang on. Run statement, execute expression, evaluate, block, run blocking no scope. This looks like the main thing. Okay, execute binding, push frame forwarding, forward context. Right, we have a frame. Oh yeah, we have a forwarding frame, and then we pop that, which should just be a forward context. Okay. But that shouldn't like do anything really. Pop frame. That logs and then deinitialize. And then we deinitialize. So okay, yeah, because this is pop frame, right? So presumably there's a different pop frame that happens, but this is like an execute binding, so where is the other pop coming from? I don't understand. Run statement, execute expression, Evaluate, block, run, execute, binding. Yeah, that's okay. That's not even. This is the first three here. Block, evaluate, execute, run statement, run statement, execute. In this is the main function. So we push and we pop once. Push forward. Yeah, this is not the place where the issue happens though. That's not the place. Man, this is okay. Yeah, I have to go soon here. Alright, let's see if we can solve this thing in like, I don't know, 10 minutes or something. Because it looks like it's the exact same thing, but it's really not. This is like dispatch. This is all the way from the beginning, basically. This is in main. Dispatch, run script, and then we're done here. This is the start of the other one. So what's the difference between the call stacks, actually? Then we have script executor 187. Do we have that on the other one? Yes. Okay, let's do this. I'll copy all this and make... First free is this, and this is the second free. Okay. Now what is the difference? Yeah, you have the first two there, which you don't. Then we have basically everything is the same, except up here, where this has the inner child. Let's see here. What is the... So this is also the inner child. Why is there a difference? Like, I don't understand at all. This is 298 in the inner child, and then 283. This, we don't see 298 in this one. 298? No. Wait. Oh, but that's the wrong file. 298 from 283. Oh, I see. So, okay, so but that's exactly the same. It's so weird though. How does this lead to like the same RC and we have a difference here? Let's go and look at that. So let's look, let's see, DNIT 298 RC, 283 RC, 283, 283, 309. I mean, okay, we could also enable this to be honest, and then we can also run again. And now we're seeing all kinds of debugging messages that are that has to do with the RC stuff. So here we can see that we're deinitializing and that causes the double free. So this is the second free that we're looking at here. Now let's see if we can find the ID. So this is the first ref that gets released, and then apparently there's no other refs either. Here we initialize that ref, and that's it. Like, we only have one release. So okay, and we're doing like the initialized child is true, fine, that's like the default thing, and we're deinitializing it with dinit. Yes, so what the hell? Oh, but we're deinitializing an array list. Oh, okay. It's my stupid but trying to be smart RC deinitializing array lists and their content as well. So when we pop the frame, okay. When we pop the frame and we deinitialize it, we look for, it should be a single. Okay, we're deinitializing the ref. Now the inner, the inner type of that is a single. Come on, give me the actual thing. See, Zig doesn't do what I do. If I said this, no, it does go to the original type here. But if I do on this, it does sing. Okay, so it does the same thing. Okay, No, it doesn't. Well, it does. Okay, so it's better actually because it says both the alias and then also the actual type here. Okay, fine, whatever. But actually, okay, so the single is just it's an RC ref of this array list of bindings, right? But what's happening is that we are going through all the bindings themselves and release them, I think, for some reason somewhere. Why is that happening actually? Because we released the binding. Wait, why? Oh, is it? No, wait. Yeah, you can see first we're releasing the array list, which should probably releasing or deinitializing the underlying thing as well. And then this gets released for some reason. This also gets released. I'm not sure from where. Deinitializing array elements. I think it might be happening like in the same call. So, okay. Let's look at the memrc. I want to add maybe, I mean, this should like deinitialize the array list without deinitializing it twice. Even though it's like an RC, nested RC, whatever. Yeah, I think that's the issue. Like, let's say we have, I'm gonna take this test and then we're gonna do RC deinit array list with RC elements. I'm not sure if we already have this test though, but I think I already have like nested RC somewhere. Maybe I don't. Maybe we don't. No, here we got nested RCs, but it's not an array list though. It's not an array list. So let's actually do this one instead. RC array lists of RC. So we have an array list of RC. What the hell? Okay, let's do zig. Let's do like zig test. Oh shoot! Let's disable this for now. Okay, so what is this? Seg fault, what the hell? 362. Okay, so this happens in here. Zig test created. What's happening here? Dnit slice. Where is this one? This is the first test. Ref get. The first test fails. So first test. Okay, let's look at the usage here. So first we created RC. You're not really supposed to do that. You're supposed to create like a ref. So we'll do that, and we'll do dupe. Okay, that's the proper way. Actually, yeah, ref. Now that's a thing. And then this is the actual ref here. And we'll initialize that. And now to get the RC, you have to do like this. And this, and then we try to get another ref, which we should use ref.ref. There we go, and then we do that, and then ref rc refs. Whoops. Refs. This should probably be like a convenient function actually on ref to get the number of refs. I'm not sure if I actually have that. Ref clone, I'll get now. Refs. And it's like if RC. So basically const RC equals to self RC or else return 0, return RC refs. There we go, that's a little bit easier and safer. So now we can say dot refs instead. Okay. And what's going on here? Get the pointer. Sure. Whoops. Wait. Oh, I see. This is the underline pointer. Yeah, sure. Why not? Okay, let's try. Three arguments found two. Value. Oh, I see. Options. That's right. There we go. Expected that found this. Right. These need to be vars. Okay. Still issue here. Segfault. Still segfault. In the same way, I guess. So we both are released, and it tries to decrease. What the hell? So it's like this one should happen, then it fails, right? So this would be the initial, yeah, that one. It releases, and then this fails. For some reason we do have like a pointer, but this fails with a seg fault. So it means that this pointer is like not correct then. For some reason. I'm not sure why. It worked all up until, I guess, the first initialize. Because what's happening here is like, okay, we get, if we have one thing here, we call release. And this one checks, okay, if refs is less than or equal to 1, we do a deinitialize. Oh, I see what's going on. We deinitialize first. Okay, yeah, this was actually a recent change. We deinitialize first with like, yeah, okay. Oh my god. We shouldn't get in here unless... Yeah, I think we could just do this then. If this is 0, then we deinitialize. Because we shouldn't even get in here if... Yeah. If we already deinitialized. There we go. All test passed. Okay, cool. I should have tested it. I should have ran the tests. But they're kind of annoying to test now because we have this this thing here. I'll just do this so we can more easily test it later, I guess. Okay, now let's see. But does it still work though? No, it doesn't. We still have the same issue. But the tests work. Let's see if we can mimic this entire thing. So basically, we have an array list of things that are bindings. Now these are not RCs themselves, but they do have RCs on them, I think. So if you go to scope, yeah, this is an array list of bindings. The binding is a union enum, but it has a deinitialize function here, which just calls the initialize on the underlying thing. Now if it's an RC, we call the initialize on the RC here as well, which we also do here. However, yeah, but that should be correct, right? We just call the initialize. And then we also call the initialize on the value, binding value itself, which calls the initialize there. Interpreter scope 202. RC 309. Man, I should have looked at that first. Holy shit, that's like at the top of the thing. This one is an issue. Okay, because this holds the binding value itself. I mean, okay, we could change it to be a pointer, I guess. The thing is, the pointer is... Oh my god, okay. I should have just made the whole thing an RC, actually. I mean, yeah, this is annoying. We could also change this to be, or we could change this to be a union. No, but that's so weird. Okay, what if we just change this to a pointer? Then we have to do a bunch of stuff, right? Okay. Okay, but we know the issue now, so we can solve it. I could just add a to-do here, actually, because I need to go now. So I add a to-do here. Well, this causes a double free when we release the mutable RC and in the scope, or while popping the scope. Yeah, so now we at least know where this error is. So okay, but yeah, that's gonna be it for this time. I'll just write down what we've done. The hover, wait, what did we do actually today? I don't remember. I mean, this is kind of mixed with what we did like yesterday, I think. We did some LSP stuff, type checker, parser. We fixed some parser issues with the tokens there. I just want to get this down so I can like keep track of the progress a little bit at least. The document store. Oh yeah, there was like an issue with the type checker on the. All right, yeah, we basically fixed some issues. All right, well, that's gonna be it for this time. So yeah, thank you very much for joining me, and